So there's a few applications of magnetic forces on current carrying conductors, and I don't want to go into incredible detail on these examples here, but your loudspeakers, so basically speakers use magnetic fields, use a little bit of current through a current carrying conductor, whether it's a coil of wire or a straight wire, doesn't matter. The current moving through the coil causes the cone to vibrate back and forth, or if you're dealing with the older scale ammeters, voltmeters, or what they call a galvanometer, they use current moving through a little coil, and that current moving through the coil in a magnetic field is calibrated to measure current and voltage in an electric circuit. The key thing to remember in these cases is that you have to have a permanent magnet in these cases, and if you look at the loudspeaker at the front, there is a permanent magnet. You look at the galvanometer down at the bottom, there's a permanent magnet. And it's got to be a coil of wire inside that magnetic field. So the little coil of wire on the cone is inside that magnetic field. And it's not just having the coil of wire that's going to cause this vibration or cause this force, but if there's current moving through that coil of wire, which is what your receiver does, your receiver will send an electric signal through the wire, and that signal interacts with the magnets and causes the cone to vibrate back and forth. What makes speakers, high quality speakers, will be the magnets in the speaker. Every speaker's got magnets, but really good speakers will have very powerful magnets in them. Very powerful magnets are expensive. And the cone will be made of some very, very lightweight material that could really be very sensitive to tiny movements or tiny pulses. A really good speaker will have a durable yet very lightweight cone, and they tend to have some really good conducting wire in there. Gold plated or copper wiring is really good at transmitting the signal along. That's what causes your speakers to work at optimal performance, I guess is the best way to think. A really good receiver can pick up very sensitive signals. A really good coil, really good magnet, really good cone in your speaker will also cause your music to have less and less distortion. And it's basically the interaction of the current in the magnetic field that causes the cone to vibrate back and forth. What they use in a receiver is something called alternating current, which means the current's constantly going in different directions, so that changing current will always give you a changing force, which will always cause the cone to vibrate constantly. When you look at the galvanometer at the bottom, we have the same kind of scenario. We've got a permanent magnet. We've got a coil of wire inside that magnetic field. In this case, there's a little spring that gets twisted because of that current running through it. And that little bit of spring twist is calibrated to represent the entire current in the circuit. So there's only a little bit of current flowing through the galvanometer, but it's calibrated so that it gives you a representation of what the total current would be. So you have to have a nice set of magnets, really good wire, and constantly changing current to keep getting your results from your speakers or from your galvanometers.